Okay, so welcome back. What we will be doing today is I will explain the second part of the OVS lab sheet. The first part of the OVS lab sheet is essentially for you to install the software and try to configure in a most basic way the first network card, the bridge network card, on your cloud. After that, we will need to configure 3 more network cards that belong on different networks. So essentially, by the end of this lab sheet, we should have 4 different network cards in our cloud that belong to 4 different subnets, and we should be able to build virtual machines so that we can get internet access to the outside world through those networks. Okay. Now, in order to do this, lots of things have to happen. The first thing that we need to do is we need to install OVS, obviously, and we need to configure it so that it knows about the bridges that we're using. So with these sort of commands that we used here, and then the same for networks 30, 31, and 32, we have created the provision in OVS to actually have devices in the system so that we can use them as switches for our cloud. Now we also need to configure those devices. So once you get to the part that it says OVS VSETL show and you have VMnets 28, 30, 31 and 32, you then need to actually configure them as devices, as network cards onto your system. In order to do this, we need to create some files. These files are the IFCFG net something files. So you should have an IFCFG net 28, net 30, net 31, net 32. Now they can all be created by copy and pasting the contents of this file from the lab sheet. However, you need to make certain changes and you need to be careful about those changes. So I will explain this on a pretty much line by line basis on what should actually be on each of these lines on these files. So we have the type Ethernet. So we have the type Ethernet. We set it to not boot up onto the network straight away. We have it to have a default route. And later on, essentially, we reach this line, which is the name. I don't know, can you see this? I think I can make this bigger actually. Okay, so the first important change that you need to make is the name of the device. All right, so the device should be called net28 only if you're dealing with the device net28. Later on, when you create the IFCFG files for nets 30, 31, and 32, this line needs to be changed correspondingly to net 30, 31, 32. And of course, the same has to happen on the next line, which is the device that you define the device that you want to be using for the configuration file. So you need to make sure that you change the names on those two lines. You leave on boot to yes, so you want these devices to come up every time you start the computer, and then you need to give them an IP address. Now for net28, the IP address will be 28 dot whatever your Prometheus had as an IP address, so it should be from 51 to 58, from 51 to 98, sorry, okay. And then most importantly, the prefix will not be the same for all of them. All right. So the IP address for net28 will be 28 dot whatever you have. For network cards 30, 31, and 32, this will be your first usable IP address from the a2.net subnets file. So it's this one, and I'll make this a bit bigger as well. Okay, so we're talking about this row of addresses here. So you will need to figure out which computer you're working on, obviously, which name, and then you need to get a corresponding first usable IP address, and that's what needs to go into that file. So your net 30, for example, if you were working, let's say, on Latifi, your net 30 should have an address of 30.25. All right. Now, once you have the IP address for this, you then need to fix the prefix. The prefix is 23, and that defines the length, the size of the network. 23 means that we're using 23 bits of our subnet mask. All right. Now, if you have never seen this before, a subnet mask looks kind of like this. All right. So it's 4 parts, 8 bits each, so you have 32 bits in total out of this. So this subnet mask here is the binary form of 255.255.255.0. Okay, so if we're using a /23, it means that we're only using 23 bits out of those 32 for our network bits, which means that our subnet mask will have to look like this. Alright, if our subnet mask looks like this, once we convert it back into decimal, this will change to 254. How? We have 8 bits and we want to convert them from binary to decimal. The binary to decimal conversion means you start at the first bit on the right, you start at 1, and then you double it for every bit that you move on. So 1 becomes 2, 2 becomes 4, 4 becomes 8, 16, 32, 64, 128. Add all these guys up, 255. Right. If we're converting this one, we're only using 7 of these bits. We're not using the last bit, so we're not using the 1. So 255, you take out the 1, 254. Okay. You will need to know how to do this. So practice a little bit maybe at home. Also, there are tables on the internet which will give you the conversion straight away. And you'll need this for the exam. This is like the longest question that you'll get in the exam. Okay. So this is why that is a 23. It is a 23 for net 28 because of how we're using network 28 in the lab. We're supernetting our lab and we're using subnets 28 and 29 together. The default gateway for this is 28254, so everything is the same as before, and the DNS will always be the same for all of the files, 28251. If now we move on to, let's say, net 30, this will be a 30 dot something IP address, your first usable IP address. This prefix will change. It will change to 30, because if we look at our A2net subnets file and we go all the way down, we're now using 30 of those bits. We've only left 2 bits free in the end. So all of this is our network part, and these are our subnet part, and these 2 bits are our host parts. Okay, why did we do this? We did this because we have 48 computers in the lab. So we have 48 computers in the lab, and we want to take the entire Class C sized network that can fit 255 computers, that starts, let's say, at 30.0 and goes all the way up to 30.255, and we want to split this so that we make enough pieces to support our 48 computers in the lab. So we can only split this in powers of 2 because the thing is binary. So we can have one slice from 30.0 to 30.255. We can have 2 slices from 30 to 128, and then from 30 to 129 to 30.255. We can have 4 slices, 8 slices, 16 slices, 32 slices, 64 slices. 32 slices are not enough because we have 48 computers, so we need to have minimum 48 slices. So essentially we're going for 64 slices. All right. So to divide this network into 64 slices means that we reach and cover the 48 computers that we have here, and then we leave about 16 pieces here, slices here, for good old me to play around with. All right. So I'm using for my computer the last bit. Okay. So this means now that because we split the network into 64 slices, we need to change our subnet mask. All right. How many 64s fit into 256? 4. Yeah? So because we split it like that, essentially we split it in 4, this also tells us pretty much the number of hosts that we will have available to use. So the first computer can use from 0 to 3. 0, 1, 2, 3. Yeah? The second computer can use from 4 to 7. The third computer can use from 8 to 11, and so on. So they can only use 4 addresses, 4 numbers. All right, because we've divided 256 by 64, that gives us 4. So 4 left for each of the slices. How do we depict 4 numbers in binary? How many digits do we need? Just 2. 0, 0, 0, 1, 1, 0, 1, 1. Okay, so we only need 2 host bits because we only need to depict 4 different numbers, 4 different combinations. This means that the rest of it will become ones. It will be enabled for our network part. And that's why we have 30 bits here, and that's why our subnet mask is a 30-bit long subnet mask. And if you take out the zeros, the 2 last zeros out of here, just as it is here, so if I take another one off here, this 254 will become 252. Hence, why the subnet mask is 255, 255, 255, 252. Okay, so now that we know what addresses we need to be using for this, the prefix will always be 30 for your internal networks, for networks 30, 31, and 32. Okay, don't get confused and put 31 bits on net 31 and 32 bits on net 32. It's wrong. All right, 30 bits for all 3 of them. After that, we have to deal with the gateway. Now, the rule generally for default gateways is your gateway is the next IP address you see on your way towards the internet. So you're configuring this network card to be inside your Prometheus virtual machine, okay? And you're providing access to a different network from the one that each of these network cards is. All right, so you're gonna give it the first IP address you see on your way towards the internet. There's 2 ways to do this. You can use 28254 if you want, but because we will route later on, strictly speaking, the next IP address you see is your host's IP address. All right, so if you have Columbus, our default gateway, which is 28254, then your physical computer is on 28.1, then your Prometheus is going to be on 28.51, and then your network 30 network card is going to be on 30.1 behind it. So the next network card you see is Prometheus's actual IP address on the virtual machine. So it is going to be the 28.51 IP address. All right, so this bit here needs to be the IP address of net28 on your computer. All right, DNS server will be the same for all of them. So once you have configured all 3 of those files, net30, net31, net32, and once you have done their OVS commands and you've created the bridges in OVS, you should definitely have in your logbooks 2 screenshots, one of OVS vsctl show, that will show you all 4 bridges and all their ports, and that should have no errors on it now. And you should have an ifconfig that shows you your ENS33 that has no IP address, your net28, net30, net31, net32 network cards with the corresponding IP addresses. All right. So now that you've created those network interfaces on Prometheus itself, it's time to create the network cards that you will give to your virtual machines inside the cloud. So in order to do this, you need to go inside your cloud in Sandstone, and you will need to give the IP information in there for the network cards that will actually exist in the virtual machines inside the cloud. So now we're moving one step further away from the actual network cards that you just created on your virtual machine. The IP address for those guys will be your second usable IP address. So if your net30 network card had a 30.1, then your network card for net30 inside the cloud, your VMnet30 will be called inside the cloud, should have an IP address of 30.2. It should have a subnet mask of 255, 255, 255, 252, because we are working on the same 30-bit long network. All right, and it should have a default gateway of 148.197.30.1. So your first usable IP address, because the first IP address it will see on its way towards the internet it will be Prometheus's network 30 IP address. So that will be the default gateway. And the DNS server will be the same, 28251. All right. Now, once you've done this, you will have configured pretty much everything in the lab set. Okay, you'll have configured everything in the networking and the cloud part. So you will have your net 30, 31, 32 on Prometheus itself. You will have the network cards available VMnet 28, VMnet 30, 31, 32 in the cloud. And if you want to test if they work correctly or not, you have one virtual machine instantiated already, or maybe not, your VP0. You can go to that virtual machine, detach the bridge or net28 network card, and attach one of the newly created network cards. You don't even need to shut it down. All right, you can do it on the fly. Once you attach the correct network card, you can then go inside the virtual machine and you can set the correct IP addresses in the network configuration GUI that you have in there. So you can give it all of the IP addresses and then you can try pinging. Now what will happen here is you will be able to ping your first usable IP address, your net 30 on Prometheus, because you are directly connected onto it. It's your gateway. You will also be able to ping Prometheus's net 28 address, and in fact you will be able to ping your net 31 and 32, because these are all IP addresses, all four of them, that belong to the same computer whose internal routing, packet forwarding will do the job, will send packets across. But you will not be able to ping any further than that. So if you are sitting on 28.51, you will be able to ping 28.51, but you will not be able to ping 28.1, which is your physical host, or you will not be able to ping 28.254, which is our Columbus gateway for the lab, and of course not Google. All right. This happens because we're trying to jump over different networks. We're trying to go over from network 30 and onto network 28 and beyond. The fact that we can ping our 28 IP address on Prometheus is a happy coincidence, anomaly, whatever you want to call it. It's only because it's on the computer where the other network cards that are the default gateways of your virtual machines of the cloud actually are. So the internal packet forwarding of that machine will handle it. You cannot ping beyond it because it's on a different network. In order to ping along different networks, you need to have routing in place. So to do this, we're going to use something called Quagga, which is a routing daemon in Linux. It's very old, and every time I use it, it just reminds me of how old the distribution that we're actually using now is. It is the last year we're using CentOS 7. This doesn't exist anymore. Okay, so if you're using Red Hat Enterprise Linux 8 or 9 and so on, we now use something that's called free range routing, like the eggs exactly, FRR. But it's pretty much the same thing. Same thing, different name, hooray. Okay, so what do we need to do for this? We have a routing daemon, so the software that does the routing, which is Quagga, and we have a routing protocol. In our case, we're going to use OSPF, which is an interior gateway protocol that we use for small networks inside a complicated LAN or whatever. All right. So in order to do this, we need to configure two things. We need to configure two configuration files. One of them is called zebra.conf, and the other one is called ospfd.conf. So if we go on to the module, if we go into routing utils, the files are there, and you can download them. And I will delete this PDF file because it's old. All right. So Zebra and OSPF, you download them, and they look something like this. Can I move this out of the way? Of course I can. Zebra.conf, its purpose in life is to tell us which network cards we're doing our routing on. Through which network cards on our computer we're going to advertise our available networks, our available routes to all of the routers around us. In our case, we're using net 28, net 30, net 31, net 32. Hooray, you don't need to make any changes to this file. Just download it onto your computer, save it in etc. Quagga, and that's it. Okay. But please explain in the logbook what it does. All right. So we're defining which network cards are going to be doing the routing that we want to be doing. This file is the one that will need editing on your part. So this is the ospfd.conf file. This is the file that will configure our routing protocol, and basically this will tell all of the other routers around us which networks are available on our computer to use for everybody else to know and to use. All right, so we will start with the OSPF router ID. Your router that does this routing is the Prometheus virtual machine itself. Okay, so if I'm working on computer on the first one, which is Hawthorne, I think, then this for me is going to be 28.51. This is simply your net28 IP address. Then what do we need after that? Network 28. Network 28 will need to have a /23 length, and that's it. It's 28.0, it's subnet 28, it's common for all of you, so you all have connection and access to all of subnet 28. Where it starts to get interesting is what happens after that. Networks 30, 31, and 32 will need to be the network addresses that belong to your computer. So if I go back into my subnets file, I'm sitting on Farina. Okay, my address is 51. So my network address is 30.0. Any of the other machines, these are the addresses that need to go here. All right, so then my configuration file, if I am sitting on the first computer, is going to be 30.0, 31.0, 32.0. All right. Each of your computers will have these parts different. Network 28 will be the same for all of you as it is, but networks 30, 31, and 32 will need to be different. Yes, so if I'm working, for example, on, I don't know, Russell, then my network address is 128. So I need to go here, and I'm going to go 128 for all of them. And those three should all have the same network address, because that's the range that belongs to your computer. That's the network address that belongs to your computer. All right. So you configure this file like this, you save it inside the etc. quagga folder again, and then you need to get the thing running. You can type all of this in one go, so it's 4 commands split by a semicolon. They will all be executed as one. The easiest thing that you can actually do is copy paste into a terminal, and then you don't need to worry about it. Yeah, so that will enable Zebra, enable OSPF, so it will tell them start automatically every time your Prometheus starts up, and then it will start Zebra and it will start OSPF. Okay, so it will start them running as services on the system. Of course, you will also need to enable packet forwarding with this command, again copy paste onto a terminal, and this command will stay or should stay forever in your system. And then finally, you should also disable your firewall. So if you type IP tables -F, that will stop, that will delete any IP tables rules that don't allow for your routing protocol to go through. If you want to impress me, you can also figure out how to actually let Quagga through the firewall, add the correct rule to this firewall, and still have your firewall on and have routing working. Now, once you do this, then the command that you want is root -n in a terminal. And in fact, if you type watch root -n, it will keep it running on the terminal. And eventually, after a few seconds, usually takes about 20 to 30 seconds, your routing table will have other people's networks onto it. All right, unless you're the first and only one in the lab that's done it and is working. All right. So your routing table should get populated by everybody else's networks. And once that happens, at that point, you should be able to ping google.com from the virtual machines inside the cloud. Because you've enabled routing on your Prometheus, on your host, so now your system knows how to forward packets to and from your virtual machines and the outside world. All right, so that will be the end of this labsit. So by the end of this labsit, a virtual machine, let's say VP0, that lives in your cloud and is connected onto VMnet 30 or 31 or 32 should be able to have full internet access. It should be able to ping Google and download software and do whatever you like. All right. I want you to have a screenshot of this ping in your logbook because that's the proof that the thing works at the end. Okay, so if you get to that point, it means that you're finished with the OVS labsit. Okay, you're finished with the OVS infrastructure, the networking infrastructure on your system, and you're ready to move on to the last labsit of the module. All right. Now we have, I think, still one more week, and then we have 1 week, which is the consolidation week, and then we have 2 weeks, and then it's Easter, and then 2 weeks after that, and then that's it. All right. So this essentially means that if you finish OVS by next week, that will leave you a total of about 4 weeks for the last labsit. All right. I will explain the last labsit next week, and it is quite important because essentially it's like a coursework on its own, what you need to do in there. However, it does have lots of freedom and flexibility with regards to what you actually need to do and how you actually need to do everything. All right, so yes, make sure that your networking is correct, make sure that your networking infrastructure is correct, and then all you have to do is just build lots of virtual machines in the cloud and make them do stuff. Okay, and that's it. Any questions about this? So to recap, it's very simple. You download and install OVS, you enable the OVS network cards, the bridges for VMnet 28, 30, 31, 32. You create the configuration files in etc. sysconfig network scripts for net 28, net 30, net 31, net 32. You change all of the IP addresses, subnet masks, default gateways, and all of the correct information and names in there. You set this up, and then you set up routing, and you set them up in the cloud as well with the correct addresses that you get from a2.net subnets file. The addresses on the net cards on Prometheus are the first usable addresses. The addresses that go inside the cloud are the second usable IP addresses. And then once you set all that up, you set up routing on Prometheus itself so that you can pass information from your virtual machines onto Prometheus and beyond. And then you have internet access inside your cloud. All right. Pretty straightforward. That's it. Thank you very much.